In this video, we're going to describe how to use the linear path easy graphical asset. But first, consider the following code in which a variable max is assigned 5. Then, the for loop iterates from 0 up to max, printing the value of the loop variable each time through the loop. When the loop exits, the string done is output. This program produces the following serviceable, if dull, output. However, by using the linear path animation asset, this same logic, with the addition of a few intuitive method calls, can produce output that looks like this. The linear path asset consists very simply of a background image, a foreground object that will move along a linear demarcated path. By limiting the asset's animation to this behavior, it enables us to provide a handful of functions that can be used for the animation, making it easy for students to use and time effective to fit into the classroom. So let's look at how the asset works. First of all, the asset itself will be held in a file. In the student code, there are stub pieces of code which have to be inserted in order to run the asset, and between those stub pieces of code will be the main logic of the student's programs that uses the linear path asset method calls. And finally, the student will be providing the image and sound files used as part of the animation. Let's take a closer look at how the student's code will be formatted. The student needs to do two things in order to animate the asset. First, create the asset itself, and secondly, simply animate it using the method calls provided. So let's first take a look at what happens when the asset is created by a simple object creation. The following information needs to be provided as parameters to that call: the name of the background file, the name of the file containing the moving element, and since it's probably likely that the choice of moving element file isn't going to be an appropriate scale for the background image, a shrink factor is also provided. The larger the number, the smaller the object will be after the factor is applied. So in this case, we could scale down the rocket to be an appropriate size. Note that both the background and moving element files must be .png. In addition, the starting x and y values of the path must be indicated, as well as the ending x and y values. And these two values in combination will determine the length and slope of the path. And finally, to define the path, you have the maximum number of steps in the path and also the length of the tick marks. A negative value tick mark will have the tick marks coming up above the path itself. Positive values will extend the tick marks below the path. And finally, the type of move as the element moves from step to step on the path will be specified. This is done with an integer value to choose one of the three move types that the asset provides. 0 indicates a stepping animation, which we will see here, in which the element moves directly from one end point of the path step to the next. 1 is used to indicate a sliding motion, and here you'll see that the rabbit slides from one step to the next. The third option, which is specified by the integer 2, is an arching or bouncing motion. Those are all the steps that were needed in order to create the asset. Next, let's look at the animation method calls that are available. First, we have two ways in which the movement of the object on the path can be specified. Move object can either take no parameters or an integer value. If it is passed no parameters, it will move the object one step closer to the endpoint, and if a parameter is given, it indicates the number of steps the object should move. If the n is positive, it will move the object closer to the endpoint, and if it's negative, it will be moving it closer to the starting point. We also have a specific method to move the object backwards if students find that easier to use in terms of their logic. The method move object backwards can also take either no parameters or one parameter. If move object backwards is not passed a parameter, it will move the object one step closer to the start point. And if it is given an n value, it will be positive and it will move the object n steps toward the starting point. So again, an object can be moved close to the starting point either by passing a negative value to move object or by calling the method move object backwards with a positive value. The asset also provides the capability for the object to fall off the path end. And here we put fall in quotes because it can either fall downward or frankly upward depending on the parameters you pass it. So there's two options. Fall forward is called if you want it to fall off the end point of the path, and fall backwards would be called if you want it to fall off the path at the starting point. In both cases, the method is passed an x and y value that indicates the distance from the path that the object will land. X, of course, specifying the horizontal distance, negative being left and positive being right, and y specifying the vertical distance, negative being up and positive being down. A method is also available to spontaneously change the image that is shown as the moving object. This method, setMovingElement, is passed two parameters, the name of the new file containing the image that you want to use, and just like the original object, that file needs to be a PNG file so that any invisibility as part of that object is preserved. And also you would specify a new shrink factor because, of course, that new object might not be the same size as the original one and would need to be shrunk by a different factor. Once this method is called, the image in the new file name will be displayed as the moving object. And finally, we have three calls for sound. First, setMoveSound enables you to set a sound that will automatically be played at each step. The default assumption is that the steps are silent and there is no sound associated with them, but if you do want to associate a sound with each step, you would simply call setMoveSound, passing it an MP3 or WAV file to be played at each step. To return to silent movements, clearMoveSound can be called and it will disassociate any sound from the movements. And finally, if you just spontaneously want to play a sound, you can call the method playSound, passing it again a sound file name that's either an MP3 or a WAV file, and when it's called, it will immediately play the sound that is in the sound file. Remember, the linear path asset, the student code, as well as all the image and sound files must be held in the same folder. To make using the linear path asset as plug and play as possible, a template has been provided in which the programmer simply needs to insert their own code in three different places. First, initializations for variables that will be used both for the linear path asset as well as for the program itself will be placed between the two comments specified. Then the user will create the asset, providing the initial information needed to create both the image and the path. And finally, the primary logic for the code will be inserted in the animation loop. This is where the primary logic that uses the animation will be located. It should be noted that the animation loop is controlled by a variable called looper, so that when you're ready to exit the loop because your animation is finished, simply set the looper variable to false. Now let's take a closer look at how the Rocket Launch program's code fit into this template. For its initializations, you can see that the background image was set to launchpad.png and the moving element was set to rocketnoflame.png. Notice that they are both PNG files. Having a PNG file is particularly important for the moving element because you do want to preserve any invisibility that's part of that image. You can see the shrink factor for the rocket was set to 3 because the image was too large in proportion to the background. The starting points of the path are 200 and 400, and the ending x and y coordinates are 600 and 400. Notice that the y coordinates are the same, which will create a path that is level. The maximum number of steps in the path is 5, and the tick length is -20, meaning that each tick will be 20 pixels in length and above the path. And the type of move is selected to be 1, so it will be the linear or sliding movement. These are all the values that will be needed to initially create the asset. We then have some additional files. In particular, we will be associating a beep sound with each movement of the rocket. And at the end of the path for the rocket liftoff, we will change the moving image to an image called rocketwithflame.png. And again, this will be its new shrink factor. And for the blast off, we will also have a file that will play the blast off sound. Finally, we have the values that will be used for falling off the end of the path vertically to simulate the rocket launch. Notice again that the vertical fall is a negative value, which is the upward direction. Next, let's look at where it creates the asset. Here we are placing the reference for the object into a variable named O. Any name, of course, can be used here as the variable. Just make sure that you then use that variable name every time you call one of the animation methods. The call for the beginning should be the same based on the contents of this template, followed by the parameters to set the initial image and path, which are the background file, the moving element file, the shrink factor, the start x and y coordinates, the end x and y coordinates, the number of steps in the path, the tick length, and the move type. Finally, between the specified comments will be the primary logic code that uses the animation methods. The first thing the code does is to set the beep sound to be associated with every move of the rocket, followed by a loop that will loop for the number of steps in the path and will move the object one step closer to the endpoint every time through the loop. When that loop is exited, the rocket will be at the end of the path, and this is the point at which we change the image to the rocket with the flame. The method fall forwards is then called to have it launch upward from the end of the path and play the rocket blast-off sound. Finally, at the end, because we are done with the code that uses the animation, we will set the value of the variable looper to false. And again, this is the end result we will achieve. The rocket sliding 5 steps to the end of the launch pad, where it is changed into an image with a flame, blasting off by falling forwards off the end of the path, and playing a rocket blast sound to accompany it. Even though the linear path asset provides just a small number of functions, the way in which those functions are combined and used with various images and sound files enables a broad range of creativity. So here's an example in which it is basically the same setup of an element moving down a path, and when the end of the path is reached, we will see the moving image transform and a sound played, but it has a completely different visual story than the rocket. In this case, we're assuming it's being used as part of a Quizzer program that will congratulate the student when they have answered enough equations in order to reach their final goal. Here we see an example where a path is used as part of a price guessing game in which for every dollar amount that a guessed price is off from the original price, the mountain climber will climb up a mountain. The point of the game is to guess the price of 3 prizes before the mountain climber falls off the top. So here you see that we have the path as a slope, and again we'll see that same behavior in which the moving element is going to transform when it falls off the end of the path, and a sound will be played to accompany it.
You're lucky.
And finally, this is a very simple looping example in which the bunny will hop toward the carrot. So you can see there was a wide variety of visual stories that could be told, and for a variety of purposes, and all of them realized by the simple methods provided by the linear path asset. We hope that you find the linear path asset to be a valuable resource for including some action in the output of your Python programs. Please see the comments below for information on downloading source files as well as sample programs.